You know, prime numbers are, well, they're kind of the atoms of arithmetic, right? The fundamental building blocks for every other number. But when you look at them, 2, 3, 5, 7, 11, 13, and so on, the sequence just seems completely chaotic. It's like a random string of digits that has left mathematicians scratching their heads for centuries, trying to find some kind of pattern. But what if I told you that hidden inside all that chaos is a stunning geometric pattern? Seriously, if you plot the primes in a very particular way, they suddenly arrange themselves into these gorgeous, almost mysterious spirals. So the big question is, why? What in the world does this tell us about the fundamental nature of numbers themselves? All right, so let's dive right into this thing. First off, what you're looking at, it's not a photo of some distant galaxy. Nope, that's a plot of prime numbers. The rule for making it is actually pretty simple. For every single prime number, let's call it p, we just plot a dot. Its distance from the center is p, and its angle is also p. You can kind of think of the angle like the hand on a clock. We're just turning it by p units, which are called radians, for each new prime. At first, it's just a jumble, a total mess. But as you plot thousands and thousands of them, these incredible arms just emerge from the static. It's wild. I mean, look at that. This image just screams order, doesn't it? It really feels like we've stumbled onto some kind of secret map to the primes, a deep structure that's been hiding in plain sight all along. So it really makes you wonder, what's the key to this map? Now, your first thought is probably the exact same one I had. This has to mean something profound about the primes themselves, right? It looks like we finally hit on some kind of visual key to how they're all spread out. But the story is actually a little more complicated than that. And honestly, it's way more interesting. See, it turns out that the first layer of this whole mystery is, well, it's actually a beautiful illusion. But once you peel that back, it reveals an even deeper truth. Okay, this is where things get really interesting. Let's use the exact same rule, but this time we're going to plot every single whole number, not just the primes. And look at that. The spirals are still there. In fact, they're even clearer, and there are more of them. We can actually count them. They're exactly 44 distinct arms. So why 44 arms? What's so special about that number? Well, it all comes down to this really neat mathematical coincidence that involves pi. Okay, so a full circle is about 6.28 radians. It just so happens that if you turn by 1 radian 44 times, you end up almost perfectly back where you started, after making about 7 full rotations. Because every 44th number lines up in pretty much the same direction, they create these super clear spiral arms. And that ratio, 44/7, it's actually a pretty famous approximation for 2 times pi. So the crucial point here is that the spiral structure itself is basically an artifact of the coordinate system we're using. You could plot almost any long sequence of numbers this way, and you'd get these arms. They're a gorgeous illusion, for sure, but they are not a special property of prime numbers. But hey, don't be disappointed, because realizing the spirals are an illusion is exactly where the real mystery actually begins. The interesting question isn't why are there spirals? The question is, what do the primes do to those spirals? Okay, let's just look at them side by side for a second. The plot with all the integers has 44 clean, continuous arms, right? But the prime plot, it's just full of gaps. I mean, it's missing 24 of those arms entirely. They're just gone. And that is the real puzzle. If these arms are just artifacts of the math we're using, why do the prime numbers seem to systematically avoid certain ones? Why do they choose to live only in specific lanes of the spiral? Well, the answer actually lies in the number 44 itself and its prime factors, which are 2 and 11. So think of each of the 44 arms as a lane on a giant cosmic highway. One lane, for example, contains all the numbers that are 2 more than a multiple of 44. The next one has all the numbers that are 4 more. Well, all the numbers in those lanes are going to be even, right? So prime numbers, except for the number 2 itself, just can't live there. The same thing happens for any lane that's built on a multiple of 11. These lanes are basically forbidden territory for primes. And this, right here, brilliantly illustrates something that isn't just a visual quirk anymore. It's a deep, beautiful law that governs how prime numbers are spread throughout the number line. So each of those spiral arms is what a mathematician would call an arithmetic progression. It sounds fancy, but it's super simple. It's just a sequence of numbers where you pick a starting number, let's call it A, and you just keep adding another number, M, over and over again. In our picture, M is 44. That's it. And this brings us to the incredible work of a 19th century mathematician named Dirichlet. He proved one of the most important results in all of number theory. His theorem basically says this. As long as your starting number a and your step size m don't have any common factors, then that sequence, that spiral arm, is guaranteed to have an infinite number of primes in it. So what we're looking at isn't a random pattern or some visual trick anymore. Not at all. It's a direct visualization of a fundamental law of numbers. Dirichlet's theorem is a reason those 20 allowed arms light up with primes, and it's the guarantee that they will keep lighting up forever, no matter how far out we zoom. But as beautiful and clear as this law is, it doesn't solve the whole puzzle. In fact, this is where it gets really mind-bending, because it takes us right to the very edge of what we currently know in mathematics. Look, Dirichlet's theorem is incredibly powerful, don't get me wrong. It tells us that primes will show up in those allowed arms an infinite number of times, but it gives us absolutely no clue when or where the next one is going to pop up. The spacing of the primes along each individual arm, it still seems completely, totally random. And that question, how to predict the precise location of the primes, is the subject of what is probably the most famous and most difficult unsolved problem in all of mathematics, the Riemann hypothesis. If it were ever proven, it would give us a map to the primes with just breathtaking accuracy. And this brings us completely full circle in the most mind-bending way possible. A recent research paper has proposed a truly stunning connection that these prime spirals we've been looking at are, in a sense, holographic projections of the very mathematical objects that are at the core of the Riemann hypothesis. I mean, think about that. In other words, this simple geometric pattern might actually be a shadow of math's deepest and most elusive secret. So, this whole thing started as just a playful experiment in visualizing data, but it led us through these beautiful illusions to deep 19th century theorems, and then all the way to the greatest unsolved mystery in mathematics. It just makes you wonder, right? Could looking at numbers in a new way, not just as abstract symbols, but as real geometric objects, be the key that finally unlocks their deepest secrets?